The actual question of the railways nowadays is the appearance of the surface errors on the railhead by the introduction of rails with increased strength. These errors are caused by the fatigue of the rail material forthcoming by the traffic influence. One typical error is the rolling contact fatigue, or RCF, which is a series of cracks evolving on the railhead. If these cracks starting from the surface get into the depth of the rail, then they could lead to fracture and could cause severe accidents. The railway companies take measures depending on the depth of the cracks in order to avoid accidents. Speed limitations are put into force or the errors are eliminated by grinding. The risk of the rail fracture can be minimized and the lifespan of the rail can be optimized by selecting the most effective rail grinding strategy. The eddy current measurement is widely approved for measuring the depth of the rolling contact fatigue cracks. The eddy currents generated by the changing magnetic field of a coil in the material to be measured react to the coil. The depth of the crack can be determined from the signal generated in the coil. The rolling contact fatigue crack gets first into the material with smaller angle. Then, as it gets deeper, this angle closes to the perpendicular. The damage deep is the distance measured between the top of the crack and the surface. The damage deep can be calculated from the length of the crack measured by the eddy current and the entrance angle determined by empirical ways. Railway companies apply 3 different measuring methods to measure the rolling contact fatigue cracks. The methods are adapted to the required interventions. Railway companies carry out the regular surveys of the most important lines by measuring trains. GF4, 4-channel hand-operated measuring device, makes for measuring parts of turnouts which are not examined by measuring trains, for surveys of secondary lines and inspecting the grindings of longer sections. HC scan device is suitable for local error findings and inspecting the handmade grindings of shorter sections. 4 measuring probes on the measuring trains inspect the rail surface. The measuring results are displayed in 20-meter sections, the biggest damage deep measured in the section and the frequency of the cracks. Rail grinding can be ordered upon the result of the measuring train on longer or shorter sections of the line. The section to be grinded can be accurately marked out by the HC scan hand-operated device, as well as the locations of the most dangerous cracks can be determined. The shorter, about some meter-long faulty sections are corrected by hand-operated grinding machines. These kinds of errors evolve characteristically in the vicinity of turnouts. The situation and the depth of the cracks can be checked during grinding by HC scan hand-operated device. The operator can see where grinding is still needed to reach the required margin of error. The zeroing function of the device is executed on the error-free rail surface after it was switched on. The damage deep of the cracks is displayed on the screen by pulling the sensor over the cracks. The angle of the crack can be adjusted for the calculation of the damage deep. The biggest damage deep found in the section to be measured can be seen on the screen until the device is switched off. The device gives warning signal in case of inadequate position or inclination of the sensor. GF4 device is suitable for surveying shorter or longer sections. The length of these sections can reach several kilometers. The 4 measuring sensors of the device are placed in smaller rolling trolleys separately from each other. The positions of the sensors on the railhead can be fixed in 16 different positions. The device is kept on the rail by a support bar with selectable sizes. Thus, it is possible to measure rail tracks with different gauges and to inspect used rails before reutilization as well. The setup of the measuring and evaluating software and the content of the measuring protocol correspond with the ones of the measuring trains, so the results are easily comparable. The measuring results measured by 4 sensors appear continuously during the measurement in the form of a diagram. The raw results can be displayed on the diagram during the measurement as well. The length of the crack in millimeters and the damage deep in millimeters. The measuring position, the measuring speed and the status of the battery appear continuously during the measurement. The operator can mark his experiences, observations with markers in the measuring program. The markers can be freely named and they appear with accurate positions in the measuring protocol. The measuring program of the GF4 enables the operator to mark accurately on the side of the rail the sections to be grinded by evaluating and displaying the results immediately. Thanks to the small weight of the device, it can be lifted or pulled to another rail or measuring place by only one person. There is a test piece containing artificial cracks for periodical inspection of the device. The accuracy of the device was examined by measurements carried out during the elaboration of rails provided with rolling contact fatigue cracks. Hundreds of kilometers of tracks can be measured annually by the GF4 device for want of measuring trains. The 1-channel and 4-channel devices suitable for measuring rolling contact fatigue cracks fit perfectly into the error finding and error rectifying system of the railway companies. Their joint use is part of the economically effective track maintenance.